Good morning, one and all. Today we are discussing about basic geotechnical engineering 18Cv54 for 5th semester students under module 1 of introduction with a lecture series 6. So this particular today's discussion is planning to cover Atterberg limits, consistency index, liquid limit and plastic limit test. So what is meant by liquid limit test? So before going to the liquid limit test, so the Atterberg and Casagrande, they have done lot of work to determine the consistency of the soil. Consistency means how the behavior of soil will be with variation of percentage of water in the sample. Okay, so one of the person who has done nomenclated it as limits, so at which the variation of strength takes place between a liquid state to plastic, plastic to semi-solid, semi-solid to solid state was proposed by Atterberg. Therefore, it has derived its name as Atterberg limits. Atterberg limits are liquid limit, plastic limit and shrinkage limit. So, Atul Casagrande has done a lot of research work in the laboratory, and he has formulated a procedure of conducting the liquid limit test. Subsequently, that procedure itself has been adopted in Bureau of Indian Standard Code of Practice or Compendium of Soil Mechanics by under heading IS 2720 Part 5 1985 guidelines as follows. So now what we have to do is we have to take a soil which is passing through 425 micron IS sieve. It may be a oven dry soil, it may be air dry soil. Point number 2, you have to use the instrument. This is called as a Casagrande's apparatus, which consisted of a platform, a brass cup, a rotating handle, a count, that is the number of blow count assembly, a china dish which is used for preparing the soil sample, that is water content cups for moisture determination purpose. This is a spatula which is used for mixing the water with the soil whenever we are preparing a paste like this. Now, next step number 2, you have to add a required quantity of water, mix it thoroughly, make a required consistency, and height of fall, once it is ensured 1 centimeter height of fall by using adjustable screw here, you take a spatula and transfer that into this cup as this particular fashion, and you ensure that the thickness of the soil is not greater than or it is not less than 1 centimeter. It should be exactly 1 centimeter thickness. Next, there are grooving tools for cutting the groove at the center of the sample. One is called ASTM grooving tool, another one is called Casagrande grooving tool. By using that grooving tool, cut a groove. That depth of the groove will be, now if you fill the sample 1 centimeter, depth will be 1 centimeter, and the width of the groove has been so fashionated that it will also be 1 centimeter. Afterwards, so that is step D. So you have to rotate the handle at a rate of 2 revolutions per second. When you rotate it, the cup will lift and it falls on the platform. By bombardment effect, the soil will start moving closer and closer to each other, and for each rotation we are calling it as one blow. So now count how many number of blows required for closing this first groove to a length of 1 centimeter. You record it and stop the test. Take a representative soil sample from this location for moisture content determination purpose, as I explained in oven drying method, and remove this soil. Again put it in this china dish. Don't add dry soil or water, allow them for natural evaporation. Again transfer back it here. Again cut a groove. So transfer it here as shown in B. Cut a groove as shown in C. Again rotate the handle and ensure that 1 centimeter filling takes place as shown in D. But the difference between previous step and present step is, from previous to present step it may be 2-3 minutes has elapsed. Therefore, it takes more number of blows, that is jolting of that brass cup for closing that groove. So count number of blows has taken. So code has specified that 10 to 40 blows within that range it has to take. As the number of trial increases, number of blows also increases. A minimum 5 trials you have to take between 10 to 40. Then each trial water content sample you have to keep it for oven. Next day you will get the water content. So now once you get the water content, a number of blows is known to you. So you have to plot a graph, water content versus number of blows, and you will get a flow line. At 25 mm per the blows, what is the water content? You have to determine it. That water content is called as the liquid limit water content. Okay. So now coming to the next one, that is plastic limit test. Whatever soil that you are used for liquid limit test, same soil you have to use it for plastic limit test, because when you want to classify the soil in future discussion, we are using plasticity index. Plasticity index is a ratio of liquid limit minus plastic limit. So same soil you have to use it. So what we have to do is take a 30 grams of the soil which we are used for liquid limit test. So make a thread, so of 3 mm diameter, so between the hand and the glass plate. At 3 mm diameter, it shows the sign of crumbling. Then the water content present in that stage of sample is equal to liquid plastic limit water content. If a crumbling occurs before attaining 3 mm, so soil is dry, you have to add some water. If a crumbling has not occurred after crossing 3 mm, it is moving towards lower diameter, then indication that more water is there. Add soil, remix it, make a ball, and again repeat the entire procedure. So now at 3 mm diameter, it shows the sign of crumbling. Take a water content cups. You can see here, this is water content cups, and so put some representative, that thread of the soil, for moisture content determination purpose. Average of 3 water content cup results will give the water content next day. That water content is called plastic limit water content. So now, so we know liquid limit test how to conduct, we know plastic limit test how to conduct, but we should know what is meant by liquid limit, what is meant by plastic limit, what is meant by shrinkage limit, how we are distinguishing it technically. So in order to distinguish it technically, Atterberg has given a chart. So that chart indicates x-axis water content, y-axis volume change behavior. So he has explained like this: you take a soil in a tray, add a required excess water, then the soil water suspension is in a liquid state. But if you try to evaporate that water, then slowly the shrinkage of that soil takes place. That means volume get reduces, and some crack formation take place. That state is called plastic state. If you still allow it for drying purpose, then peeling out of that layer takes place. That is called semi-solid state. If you still allow it for further 1 or 2 days, so then there is no change in the volume take place, but soil will become hard. Then it is called solid state. So what is meant by liquid limit? Liquid limit means it is a demarcation of water content between liquid state to plastic state of consistency, at which it possesses a strength of 1.7 kPa. Then what is meant by plastic limit? It is a demarcation of water content between plastic limit to semi-solid state of consistency, at which it possesses a strength of 170 kPa. Then what is meant by shrinkage limit? It is a demarcation of water content between semi-solid to solid state of consistency, so at which further removal of water will not cause any applicable reduction in the volume of the soil sample. That limit is called as WS, or shrinkage limit. Okay. So next, so we have, once we know the liquid limit, once we know the plastic limit, we have to plot the plasticity chart. The purpose of plotting plasticity chart is for classification of the soil. How to plot the chart? Take an ordinary graph sheet, mark x-axis as liquid limit values and y-axis as plasticity index value. Plasticity index is equal to IP, so which is equal to LL minus PL. So now, so this plasticity chart has divided at liquid limit at every 10-10 interval, but at 35% liquid limit and 50% liquid limit, 2 vertical lines are plotted, and that 2 vertical lines will differentiate lower compressibility, intermediate compressibility, and higher compressibility zone. And also there is a line that distinguish whether the soil is a clay or whether the soil is a silt or organic soil. So clay is represented by C, silt is represented by M, organic soil is represented by O. So which O has not written here. Instead of that, we have written that is silt here. So that is the O is a representation of organic soil. So now the A line can be plotted, starts at 20, because anything with a liquid limit less than 20, you don't have plastic limit, or if you get a plastic limit, we will say that it is a non-plastic soil. So now the one more coordinate to plot this line we require. To get that coordinate, we have to use formula 0.73 WL minus 20. WL is your liquid limit value, which you obtain from Casagrande method. So now, if a liquid limit is 0 to 35, whether it is above a line or below a line, it is lower compressible soil. If it is above a line, it is clay of lower compressibility. Below a line, it is silt or organic soil of lower compressibility. If it is 35 to 50, it is a clay of intermediate compressibility. Above a line, below a line, it is silt or organic soil of intermediate compressibility. If your liquid limit greater than 50, and generally it is up to 100, some China clay will be more than 100 will be there. Therefore, I am using word if it is greater than 50, above a line we are calling it as clay of higher compressibility. Below a line we are calling it as silt or organic soil of higher compressibility. This is the plasticity chart which is used to find the classification of the fine grained soil. So we are uploaded MCQ questions in LMS software. You please go through the today's discussion related MCQ questions. If you have any doubt, answers also we are uploaded. If you still have any clarification doubt, you can feel free to ask in the next class. Thank you for attending the class.